right, welcome back. The next speaker is from Heinrich Heine University, Düsseldorf, Germany, the one and only Professor Gerhard Schurz, and his topic is Inductive Metaphysics and its Abductive Methodology. Thank you.
So I'm happy to be here on this wonderful conference. Thank you also for organizing this wonderful conference. And I start with the introduction. So according to the dominant tradition, metaphysics is considered as a conceptual and a priori discipline. But there is an alternative a posteriori conception of metaphysics with informal roots going back to Aristotle, and this has been called inductive metaphysics. And this term was coined by philosophical developments in the late 19th and early 20th century. Oswald Külpe and Ernst Becher and others were coining this term, although informally it has roots already in antiquity. And a general characterization could be this: inductive metaphysics aims at an a posteriori justification of metaphysical claims based on ampliative, inductive, and in particular abductive inferences from empirical data. And inductive metaphysics is embedded in a methodology that closely resembles that of science. And if you relate that to traditional conceptual metaphysics, then the thing is, these a priori methods, such as conceptual analysis and concept explication, are still considered as an indispensable part of metaphysics in inductive metaphysics. So inductive metaphysics doesn't deny that conceptual analysis plays an important role, right? So concept explication, what is just claimed is that the justification of many important metaphysical beliefs cannot proceed in a purely a priori manner. But they need empirical input, so to speak, empirical input, empirical premises, and abductive inferences from this input. That is the claim. But of course, before you start, you have to have your concept explication. That is not denied. And there will be a volume, by the way, entitled Inductive Metaphysics, which will appear end of this year with Routledge, where there are papers about inductive metaphysics, both from our research group in Germany, which has 7 universities unified, and half of the papers are from philosophers all over the world. Okay, so just for information. So, but here I focus, and in my work I focus on the role of abduction to inductive metaphysics. Importantly, in the term inductive metaphysics, which comes from the late 19th century, the notion of induction is understood in a wide sense, so meaning all kinds of non-deductive, uncertain, and as you also say, ampliative, so content-expanding inferences. And this is important because this wide understanding includes also abductions, or inference to the best explanation, as one kind of induction in the wide sense. In contrast, induction in the narrow or Humean sense means the projection of observed regularities to unobserved or to future cases. Now, with this narrow human sense of induction, this is not enough, right? With this human induction, you cannot introduce new concepts into the conclusion. So you cannot transcend the range of what is observed or what is observable, because you just project the observations from some instance to new ones. But metaphysical concepts and principles speak about unobservable entities or properties. In this respect, they are similar to theoretical concepts and principles in science. So this was an important insight in what I call, or what is called, the post-positivist philosophy of science, that theoretical concepts such as force cannot be semantically reduced to observable concepts. And the conclusion is that abduction is needed whenever one reasons from observed phenomena to hidden entities which are not contained in the data expressed by theoretical concepts. And abduction are the only kind of inference that can introduce new concepts relevantly into the conclusion. Relevantly. This is a technical meaning I don't speak about now. And already James Peirce emphasized that. Also, in the writings of the late Peirce, abduction and inference to the explanation are roughly the same. I mean, roughly the same as Hammond's notion. Because Peirce says that abduction is the inference to a very plausible or most plausible hypothesis. So I use here the notion of abduction and inference to the best explanation synonymously. The expert here, excuse, there's a historical debate about these two notions are related. They are not exactly the same, but for my purpose here, I can use them as roughly the same, right? Okay. So, but I mean, what is the difference between theoretical concepts in science and in metaphysics? Theoretical concepts in science describe unobservable entities like electrons or relations like forces that explain the observed phenomena in a unified way. Concepts in inductive metaphysics are similar to theoretical concepts in science. They go beyond the observable to offer unified explanations of the whole of experience, so to speak, both in science and in everyday life. What distinguishes metaphysical concepts from theoretical concepts in science is their more general nature, but I say it is their transdisciplinary nature. That is my focus here. For example, the notion of force belongs to physics, but the notion of cause belongs to metaphysics. I mean, so cause is also used in the social sciences. If you have, of course, I mean, there was an objection 2 days ago, I don't know. Force is defined, for instance, in classical physics, in Newtonian physics. You can, of course, define a physical notion of cause, but the notion of cause in social sciences will not fall under it. So cause really is a general notion, and like in the causal graph, in Bayesian causal nets theory with the Markov condition, you have such a general notion of cause defined by an implicit axiomatization and so on. That is what I mean with transdisciplinary. You really have transdisciplinary concepts, and that is really one sharp discrimination criterion between metaphysics and physics, for instance. So that is my thing. Also, for instance, the notion of conservation law belongs to physics, but the notion of a law of nature or law in general is more general. I mean, you have laws in biology, you have laws even in psychology, maybe in sociology, people speak about laws too. So this is the general transdisciplinary nature. Okay. And not only theoretical science, but also inductive metaphysics needs abductive inference. So, okay. Now, what is abduction? Usually the general abduction pattern is presented in these ways. There's a surprising fact, there's a background knowledge, and there's an explanatory hypothesis, which is the best explanation of the surprising fact, given the background knowledge, among all considered or conceivable alternatives. Okay. Now also, there are two major families of abduction. Selective abduction search for explanations of particular empirical facts by known laws or theories. For instance, you see a footprint on the beach in the sand and infer by theories, laws which you know, someone has walked here. So these kinds of selective abduction cannot introduce new concepts because you know already the laws by which you infer retroductively, and so you know already the concepts which describe the causes of what you observe. So the other family has been called by these three authors creative, or I also call them theory-generating abductions. So here you search for explanations of some empirical facts, and usually these facts are themselves empirical generalities, regularities or dispositions, by new theories about unobservable causes. So you create new concepts, new theoretical concepts and laws at the same time. So if you prefer this word, you create a theoretical model, right? Because a model is nothing but new concepts and new laws, so it has hidden variables and so on. So for instance, the explanations of the planet's trajectories by the gravitational force of the sun, right, is such a theoretical explanation, is a creative abduction. They are less frequently studied in the literature, but they are needed for scientific theories and for abductive metaphysics, and the rest of my talk will focus on creative abductions. So the major challenge are speculative abduction. The problem is that for every set of facts, you can create or abductively infer a perfect post factum explanation by stipulating sufficiently many theoretical hidden variables. So, for instance, post facto explanations of arbitrary facts by God's wishes or by intricate conspiracy theories. Last week, the Dow Jones index went up, or maybe it went down. Unfortunately, it went down last. So God made this to support or to punish Trump as it comes, right? So this is a post factum explanation. And in this, or some other power did it. Maybe Putin, I don't know. So his conspiracies. For every observed fact, here a new wish of God has been postulated post factum. I mean, so it's a kind of metaphysical duplication. I think that speculative abduction are without scientific or epistemic value because, first, they do not provide unification in the sense that a set of elementary facts is reduced to a smaller set of elementary principles. This is a theory of unification which has been explicated by different people. And the word elementary is important here. It can be defined technically. Otherwise, the theory of unification doesn't work. Okay, so it doesn't provide unification, and these post factum abductions are not potentially predictive in the sense that you cannot predict what will happen from this kind of abductions. Of course, if you have a theory about God's wishes, you could predict it, but you don't have such a theory. We do it post factum here. The explanations generated by these kinds of abduction are potentially predictive, and this means that they are not independently testable by use novel evidence in the sense of Wall. Wall made this important point that potentially predictive means that the evidence which is needed, which is used to confirm the hypothesis, has not been used for constructing the hypothesis. It has not been used for fitting the variable parameters of the hypothesis, right? You do this also in all empirical confirmation methods in statistics. If you have a training set by which you fit the parameters of a hypothesis, then you test the hypothesis with the new test sets, which has not been used for fitting the parameters of the hypothesis. And the same is required here when I say these hypotheses must be independently testable, or they must be potentially predictive. Okay. So another example is this example, historical example, post factum explanations of dispositions. Opium has a disposition to make people sleepy. Therefore, opium has a special power, vitus dormitiva, to make people sleepy, the example of Molière. So also here, you have no unification and no independent testability. because for every temporal regularity, a new special power is postulated. So conclusion, the two demarcation criteria I propose for speculative and scientific abduction are unification first, and independent testability or potential predictiveness, second. Scientific abduction possesses these two virtues to a high degree. Most scientific abduction proceed as follows. They infer from a set of intercorrelated empirical dispositions or regularities. I mean, these two things are close together. They infer from these a common underlying theoretical property, a common cause, which I also call it. Cause in this sense, because you need the theory of causality to know really what a cause is, but cause in the colloquial sense for the time being. And when I speak of dispositions, I just mean here a law like temporal regularity, like if you have a triggering condition, then a certain reaction follows. So I don't have a kind of dispositional essentialism here in mind. I distinguish between dispositions as regularities, empirical regularities, and their causal basis. So I distinguish between a structural property and a disposition, which is also called the standard account of disposition. This is important. Okay. So here my favorite example of a common cause abduction in science is the abduction of chemical kind concepts like solubility in water. My first study is chemistry. So this is why I have these kind of examples. So here there are certain kind of substances like sugar, salt, natrium carbonate, copper sulfate, and all these salts in the general chemical sense. And they are soluble in water. But so they have this disposition. But the point is, if they have this disposition, and only if, then they have a lot of other dispositions. So I say these dispositions are correlated. So if this substance is soluble in water, then it's not soluble in oil. It is soluble in all water, similar solvents like ammonia and so on. It's not soluble in oil, similar solvents like benzene and so on. It has an increased melting point. It conducts electricity and others. So the abduction is, well, why do particular substances but not others have all these dispositions in common? There must be a common cause, an underlying common theoretical property, which is the cause of these regularities, of these dispositions. And this has been called the hydrophilic nature, water-friendly nature in early chemistry. And then later there was a model for this developed, namely the model of an electric dipole. So the bonds of these kinds of systems, of their molecules, are ionic or they are polarized. And because this water or water-similar solvents have themselves polarized bonds, they're easily dissolved. So while the non-soluble substances are soluble in oil because they have non-polarized bonds. Oil and these substances in solvents, these solvents have also non-polarized bonds, and they also like to dissolve in each other. So this is a model here. And this common cause abduction yields unification. You can even measure it. Given m substances and n correlated dispositions, there's a reduction of m times n empirical laws to m plus n theoretical laws by assuming this common cause. And also they entail novel predictions which are independently testable, because if a substance is soluble in water, this indicates that it is hydrophilic. This indicates its unobservable property, from which you can infer it will possess the other disposition, so it will not be soluble in oil. So without even ever having given the substance into oil before, from the fact that it does dissolve in water, you can predict it won't dissolve in oil. This goes beyond empirical induction. This is a really novel prediction, right? And so this is what I mean with independent testability by novel prediction. And I think that many other examples of abductions in science, like the abduction of force in classical physics from the trajectories of bodies in gravitational fields, the abduction of common ancestor from similar species in evolutionary biology, and similar examples can be analyzed in the same way, right? Okay. So, the major challenge for inductive metaphysics now. Can we say that inductive metaphysics can proceed in the same way? So, do metaphysical abduction possess these two virtues? Some philosophers reject, or have at least rejected in their writings, the transfer of abduction from natural sciences to metaphysics. Other philosophers have advocated this transfer. So I advocate it, of course, as you see. So first question, do metaphysical abductions at least possess the virtue of unification? Usually, yes. We all agree about that. Is this first virtue enough? This is controversial. I don't want to say here more about that. It's controversial. Do metaphysical abduction possess a second virtue of independent testability? Not always. Someone say, often not. Others would even say, never. I would say, sometimes yes, surprisingly. And in the remainder of the section, I will give you two positive examples where metaphysical abduction is not only unificatory, but also potentially predictive. Okay. My first example is the justification of perceptual realism by a common cause abduction. So the claim is here that the justification of perceptual realism can work in the same way as abduction in science. Although this is, of course, unconscious. So because our visual construction works unconsciously mainly. So our visual perceptions are, strictly speaking, two-dimensional, and because my visual impression of that chair depends on which angle I perceive, look at it, right? You couldn't deny that. So, but my visual, my internal perception, so my visual perceptions of these chairs from different positions are all strictly correlated. If I look from this viewpoint, I have this and this visual impression, and also, of course, they are correlated tactile perception. This is another correlation, which is important for our naive realism, right? That I can also touch these things. And the best explanation for these correlations, I mean, these correlations are really extremely powerful, right? But the best explanation is the explanation by a three-dimensional object in a three-dimensional space where this causes my position-dependent visual impressions, right? By the laws of perspectival projections by light rays, right? I mean, whatever light is, by perspectival projections. And this is really extremely powerful because I can absolutely predict. I have to look how wonderful it is. I have to look only from this position of this chair, and I can tell you if I sit there how the chair will look like without going there. I can tell you. I mean, this is a clean prediction. So Clark in cognitive science has written books about that, about this powerful prediction machine with our visual apparatus. And of course, it achieves a powerful unification. So here's the pictorial representation. So here you have the three-dimensional objects, and here you have the Kantian divide, and here you have my internal visual dispositions, so to speak. If I look at it from this position, I have this impression. I look at this box from this position, I have this impression slightly from above. If I look at an angle, I have this position from the top, I have this position, and so on. And all this, and these positions are correlated. So if I look at it in that way, this holds, and this holds, this holds, and this holds. So they are correlated. So, and I can explain not only one of these dispositions, but all of the entire correlations with this common cause abduction. This is the point here, right? So, okay. So, but is this really the best explanation of our sense experience, perceptual realism? What about the brain in the vat alternative? My proposed solution, which has been suggested also by others, like David Chalmers and others, is the following. The brain in the vat explanation assumes an isomorphic copy of the realist explanation within the supercomputer and makes additional assumptions. Like here you see in the ordinary world this tree here, and this is an explanation in the ordinary world. And here the supercomputer sends signals to our brain which cause on the retina exactly the same impressions as are caused in the normal world by the real tree and the light rays. But how does the supercomputer do it? Probably by having an isomorphic copy within the supercomputer of the ordinary real world, of the ordinary world situation. I cannot imagine another plausible explanation than this. So this explanation here has, as part of it, an isomorphic copy of the normal world explanation, but adds a lot of additional complication. So its prior probability must be smaller than the prior probability of the ordinary world explanation. So this is here my proposal. Okay. So, good. So this was the first example of a metaphysical abduction which can be not only unificatory but also potentially predictive, actually predictive. And now the instrumentalist challenge. What entitles us to assume that the abducted common cause really exists? That is the instrumentalist challenge. Shouldn't we better confine ourselves to the instrumentalist position like Van Fraassen and say, well, it's a useful tool for predicting our visual impression, but we keep silent about the real existence of this latent variable, which is that chair here, independently of my existence. Okay. And I propose theory generating abduction is justified by a causality principle. Namely, if two properties or events are probabilistically dependent, then either one is the cause of the other, or both are effects of one or several common causes. So this is a fundamental causality principle which follows from the Markov condition. It's weaker than the Markov condition. It's really very weak. But if you accept this, well, and with cause here, I mean just the causal factor, which need only to be probabilistically relevant, not the total cause or something, as it's usually in causality theory. Now the argument is this. Dispositions cannot be causes of other dispositions because they have independently realizable trigger conditions. This is a major argument. So I cannot be explicit on this here, but following from this, if you accept the causality principle, it follows that this correlated disposition must have a common cause. So here, the metaphysical principle of causality gives us a deductive justification even of theory generating abduction. The remaining problem is, how can we justify the principle of causality? And this brings me to my second example, justifying causality by a non-causal abduction. And we can have an abductive justification of causality. On pains of avoiding circularity, this justification must, of course, be non-causal. It must be solely based on unification and predictive power. Otherwise, we would be in a circle because we justify abduction by causality and causality by abduction. I mean, that wouldn't work. And I worked on this in this research project with Alexander Gebhardt, and we came up saying, based on this causal graph theory and causal baseness theory, direct cause-effect relation offer the best available explanation of two instability or stability properties of correlations, screening off and linking up. And I mean, the time is already sharp, but so here very shortly, you can, screening off means that you have a probabilistic dependence between two variables that is screened off by a third variable. So these two variables are x, y, are probabilistically correlated, but the correlation disappears whenever you fix on the values of a third variable. So, and any values, like here, barometer reading, coming storm, atmospheric pressure, or the correlation between frequency of car existence and gender, male, female, is screened off if you fix the car speed of the driver, right? For instance. And the best explanation of this fact, why should the correlation disappear if you fix on arbitrary values of the third variable? The best explanation is that there's the variable z is a mediator between x and y. It's a mediator in the sense that, which is depicted here, that there is no direct causal dependency between x and y. It's only one between x and z and y. And so the correlation, which is produced by this causal dependency, is mediated from x to z and from z to y. So if you fix the values of z, this correlation between x and y disappears. So for explaining screening off, this an undirected notion of causal dependence would be already sufficient to explain that. Directed causal dependencies are then needed if you also, in addition, want to explain linking up, because in linking up you have these properties, the opposite properties. Two variables x and y are independent, are not correlated, like the position of the sun and the length of towers. They are not correlated. But if you fix on the values of the third variables, here the length of the shadow, for example, z, then they become correlated. So, you know, if you know the shadow is very long, then you can infer from the fact that the tower is short, that the position of the sun must have been very deep. So, right? So this linking up phenomenon can only be explained by, it must also be the case that the third variable is the mediator between x and y. But now you must assume the causal dependencies are directed, because otherwise you couldn't discriminate between linking up and screening off. And you assume that changes of value distributions, so intervention, the effect of intervention, can only be propagated along the causal arrows, but not in the other direction. And then you have these three situations with these three variables: intermediate cause situations, z is an intermediate cause, common cause, z is a common cause, and both explain screening off, right? And the third situation is common effect. So z is the common effect of x and y, and this explains linking up. And this leads, as we show, to the causal Markov condition, and if it's enriched by mild assumptions, then it achieves empirical content and potential predictability. And this ends my talk. Thank you.
Oh, thank you very much. And we have 15 minutes of discussion. So there's Musa, Professor Niiniluoto.
So now this works.
And then you, and Professor Emma.
Okay, thank you so much, Gerhard.
Yeah.
A lot of thought-provoking material. I want to ask a question about your first example, because you started off by saying that, you know, metaphysics is mostly or probably solely about unobservable things, like, you know, positing unobservable entities or processes in order to explain things. But the first example that you used was from perception, which is about observable stuff, right? Your perceptual realism example, you know, chair is completely observable. If you were sitting here, like, you know, change of perspective, these are all like observables. I'm wondering whether that can serve, that example can serve as a proper, you know, evidence for your case regarding physics.
Observable in the strict sense means the point is that the theoretical concepts to which you infer is not contained in the explanandum, right? So in a strict sense, if you are at the level of foundational epistemology, what you have immediately are only your subjective impressions. So the external reality is not observable in this strict sense, right? Yeah. Get that? In this epistemological sense, you know, methodological solipsism. So what is directly given are only my subjective impression. I can be certain that there is that you are sitting, that I have the impression of you, but I cannot be certain that you're real there, because maybe you are a hallucination of mine or a hologram, or maybe you're doppelganger is sitting there. I would have, yeah, no, these are extremely improbable things. But in foundational epistemology, you have this frame. So, and in the philosophy of science, in the instrumentalism realism debate, it's well known that this is epistemological a halfway position, because it assumes realism with respect to observables, but it doesn't assume realism with respect to the theoretical concepts. So this is a point here. So this is an analogy. But the general notion is that the variables which are used for the explanations are not contained in the evidence. This is the general thing here, right? Okay.
Okay, thank you, Gerhard, for a fine and I think quite convincing presentation. Now, my question concerns explanation in metaphysics. So if abduction is inference to the best explanation, it means that we, in abductive metaphysics, we need also explanations in metaphysics. And so the question is, what are the similarities and differences between explanation in science and metaphysics? And I think the issue is that in metaphysics you might have many general principles which are conceptual, and also there are non-causal dependency relations like grounding, and which seem to be quite different from the causal explanations in science. So what is your view on that?
Yes, I think in the notion of explanation in the theory of inference to the best explanation or abduction is a liberal one, right? I mean, it is always a kind of deduction relation, or it's a relation of making something highly probable. You know, making probable is already has two ingredients in it: high probable and making probable. And of course, you can then add whistles and bells, like the what was Lipton's thing, the most beautiful explanation, lovely and likely explanation, or things like that. But I mean, they must, for confirmational business, it is in Bayesianism, what is important is the likelihood, right? So the explanational relation must be really strong. What is really different is the causal thing. So if you explain empirical facts, but also regularities, you can have a notion of causality. You know, if I explain a regularity by a disposition, by a theoretical, by a force, so I can have a notion of causal explanation too, because I can reduce this one. I can add, you know, I can add the common cause as an antecedent condition. But in the case of the explanation of regularities by directed causal relations, right? This is more abstract. This is no longer causal in the strict sense. So here you have a grounding relation, as you said. And some people, like Timothy Williamson or others, many people actually want to apply abductive relations also to systematization relations in logic, for instance, or in formal sciences. I mean, I think one can be liberal here in this respect. Of course, not too liberal. It must always be a relation of deductive systematization and or of having a high likelihood, making it probable. For confirmation purposes, this is sufficient. So, yeah.
All right, then, Valdi.
Thanks very much. My question is related to the first question about unobservability, and I wondered whether you would want that to be just at the moment unobservable or in principle unobservable, because it seems to me that, for instance, in the early modern period, people were making what you call post-factum explanations about powers, and then almost thinking of them as in principle unobservable, and that idea has carried on. So that once you get the explanation of the solvability in terms of electrostatic forces, it's sometimes assumed that if there are powers, there have to be a separate thing, the power, in addition to having the ability to electrostatically interact, instead of saying, well, the power just is to have electrostatic powers. Right?
Yeah. Okay. So the first question is very, very nice. Yes, you have to distinguish between not actual observable now and unobservable in the next 100 years, or unobservable in principle. But this doesn't matter for the theory, because even you can infer abductively that there must have been I don't know. There must have been a sea here 1 million years ago, because we find shell fossils in the earth.
Okay.
And then later you maybe get a more direct evidence for it. Or I can infer that that there must be some common cause, and later I discover it, right? A common cause that some person has been doing a lot of other things, and then later I discover the person. Yeah, in that case, the postulated hidden variables is observed later on. But I mean, I won't be able to observe a magnetic field or an electron. This is then a different thing. It depends on how far you stretch the notion of observation. The second thing is, I have the disposition. I mean by that irregularity, and I have my reasons for that. Not going with the disposition of that. And I have a causal basis, right? And the causal basis is then explicated by a model, like electric forces. So somehow the notion of power disappears. I don't need it. I mean, I replace causal powers by theoretical models. I mean, you can speak of the power of electricity if you want, but I don't have a separate notion of power here. I have the notion of an electric attraction and repulsion, and maybe of an electric field. But no separate notion of an electric power is needed. Yeah.
All right, then Jani Hakkarainen.
Yeah, thanks for this very clear talk. It seems to me that many metaphysical theories possess the virtue of unification, but that doesn't...
Implication?
Unification. Unification, but that clearly doesn't seem to be enough for deciding between the theories. And then we come to the second virtue of independent testability. So whether they entail novel predictions by which they are independently testable. And there I have a hard time to see how that could work, even in principle, in the cases like consider present competing views about ontological categories such as process ontology versus, let's say, substance mode theory or trope theory or whatever. Because I just have a hard time to see how these different theories could entail novel predictions by which they would be independently testable. But still, it makes a huge difference to our understanding of the world or being, whether we consider it or whether we consider, for example, process theory or substance mode theory or trope theory to be correct.
Yes. That is why I said unification is possessed by, but it was uncertain. I expected this challenge. Yeah. And second, I mean, for my main profession, I'm a philosopher of science, but I am broader, epistemology and so on. I got very interested in metaphysics from this angle, right? So this is a work for metaphysicians to think to which extent independent testability really applies to things like trope theory, because In the case of causality, you can really show it. In the case of perceptual realism, it's evident. In the case of, I don't know, but in the case of process theories versus thing ontologies, process ontologies, maybe it has some predictions like, there's a thing in quantum mechanics about indistinguishability of particles, right? So there are no strictly any longer particles. The electrons in the Paul Teller and other people wrote about that. So I think that maybe here we could have even have independently testable empirical effects, but I would have to think about it, and I would wish that metaphysicians think about it. And if they come up with saying that there are many alternative metaphysical theories which cannot be distinguished by these criteria, then this is so, right? And in the case of trope theory and ontologies like this, I agree. I see your problem. So some of them are maybe better in unification than others. I like trope theory for my part, but I don't hear any predictive power here.
Thank you. And then we have only 2 comments from Professor Emery and you, and we may extend a couple of minutes because we can then cut down a few minutes from the lunch.
Thanks. I also had a question about how you were thinking about explanation and including non-causal explanation, but what you said earlier was very helpful. So I'm going to ask instead about the claim. So I think you are committed to, but tell me if I'm wrong, that all successful examples of creative abduction in science involve both theoretical unification and novel prediction or novel predictive possibility. I forget the way that you stated it exactly. Potentially predictive.
I proposed it.
Yeah.
Not being committed in the sense that I would not be willing to revise my judgment if, you know.
Okay, so I've been interested in a set of cases in science where scientists are willing to introduce novel entities that are surprising or that don't have a very robust analysis. So it's sort of a placeholder for whatever is doing the explaining. So one I mentioned yesterday that I think is quite good in this context is Pauli's introduction of the neutrino. Mm-hmm. So that's an example where it's unclear to me how, maybe I'm just not understanding unification in the right way, but it's unclear to me how that is unifying in any sense. And then also it's, that particular posit was designed to not have a lot of potentially predictive upshot, because the goal was to try to figure out something that explains what was happening, that also explained why it hadn't been observed yet. So at the time, at least, there wasn't any sort of idea that they would be able to detect it or have novel predictions.
Exactly. This is the point. This is in the discussion about what an ad hoc status is. So when the neutrino was first postulated to explain the deviation from the energy conservation of this cloud chamber reaction, this has been called, it was an ad hoc postulate. You could also say, well, now in some we have a spontaneous symmetry breaking of energy conservation. You could also have this. So, but we don't like wine. We don't give up this. We postulate a particle, neutrino. But ad hoc doesn't mean negative. So the point is then you should have an independent test of neutrinos. So the existence of neutrinos implies certain other predictions. So you should have observed neutrinos in other cloud chamber reactions, maybe indirectly by observing exactly the same amount of quantity of energy is missing or something. So, and they have later on been independent confirmations of neutrinos. And at that later time, then it became unifactory and it became independent tested. And at this later time, it was no longer ad hoc. So this would be my story. Would you agree?
I think it's an interesting case study because there was widespread acceptance of the neutrino long before any kind of independent verification. So there's a fairly big gap there, at least as I read the history. But I'd be happy to talk more after, maybe.
Okay.
Thanks.
Thank you, Gerhard, for your talk. I'm Tino Nissinen, and my question might be a little off topic, but nevertheless, I was interested in the example you presented about the visual perception as a 2D image. And I found it kind of hard to maybe agree on because, for example, in the field of environmental psychology, J.J. Gibson proposed that visual perception is actually 3D, as you can see with two eyes. So you have these two pictures, and you can move around the object as you presented in the next example. So you actually get a really lively experience in the visual sense from your object.
Yeah, but that is the construction of your brain. I mean, what you really see is a perspectival projection. You see a perspectival projection of mine. You don't see the back of my head, right? Do you see it? Do you see that I have a glacier? What is the English word for Glatze? That I'm bald there, or what is the English word? Whether I have hair there or not, you don't see it. So now, you know, you don't see me as a three-dimensional object. You see a perspectival projection. That is fact. You just forget about it because you are so strongly a naive realist. Because our brains are naive realists. Because it's so much is known about the visual processes which are going on in our brain, starting from the configuration of excitation on the retina, with lateral inhibition starting with first level of neurons, second level of neurons, and so on. And you know, in computer simulations of visualization, it works so perfect because this can be modeled so perfectly. So this is an unconscious process, and the result is that you have then in your brain, you think you see it, but this is already the result of this construction. What you have in your brain is a three-dimensional object, Gerhard Schurz, who is moving around here, you know, it's rotating and so on, yeah. This, you know, so, you know, but you know that you can have optical illusions. There are these famous pictures where you, out of the page of paper, a bridge is forming out. It's completely illusionary. From these illusions, you know now, today, that this is really strong evidence for this story. And also, in cognitive psychology, it's known that there's many independent mechanisms of 3D vision. The binocular seeing is a major one. But if you are one-eyed, you can also have a 3D vision. There are other mechanisms like moving your eyes and other things where you also have a three-dimensional information.
All right. Thank you, Gerhard. Let's thank him.